Hi everyone, and welcome to the first of 4 videos going through some past paper questions on the topic of the halogens, group 7 elements. So if we have a look at this question, it's saying a student attempts to make a solution of strontium chloride by adding chlorine water to aqueous strontium bromide. Describe what the student would observe. Okay, well, if we're adding chlorine to strontium bromide, the chlorine is going to displace the bromine and make strontium chloride, and we're going to be left with the bromine on its own. So we're going to end up with an orange colour in the solution. Because the bromine is going to be displaced, right? And that's where we're going to get the orange colour from. It then wants us to write an ionic equation. So what we're going to have is we've got our chlorine, so chlorine is going to be Cl2. We're going to add that to the strontium bromide, so that's going to contain bromide ions. So it's going to be Br minus. And then the chlorine is going to displace the bromine. We're going to end up with chloride ions in strontium chloride, and we're going to end up with the bromine being displaced. Okay, and then it just needs balancing with 2 bromide ions and 2 chloride ions. Why does this reaction work? It works because chlorine is more reactive than bromine. But why? Why is chlorine more reactive than bromine? Well, these are group 7 elements. What they're trying to do is gain 1 electron to become a negative ion. So if chlorine is more reactive, it's because chlorine is able to gain an electron more easily than bromine is. Okay, so we can put that remark. So chlorine gains 1 electron more easily than bromine. Okay, but why? This is because chlorine has a smaller atomic radius and it also has less shielding. It has a smaller atomic radius and less shielding than bromine. So electrons in the outer shell are more strongly attracted to the nucleus. So what that then means is it's easier to attract an extra electron and gain it. So the idea is that because chlorine's a smaller atom, the outer shell is closer to the nucleus, and there's fewer shells of electrons in between the nucleus and the outer shell. So you've got less of the negative electrons in the way, shielding the outer shell from the positive charge. Okay, so therefore it's easier for the chlorine to gain an electron. And this is where you get your marks. It's a 4-mark question. So the fact that chlorine gains an electron is worth a mark. Smaller atomic radius is a mark. Less shielding is a mark. And therefore there's a stronger attraction to the nucleus for the 4th mark. Right, then we've got a reaction here. So fluorine is too reactive to use, powerful oxidizing agent, it reacts with water, complete and balanced the equation. Right, so if fluorine's reacting with H2O, we've made the oxygen, so the other product must be HF. Because the hydrogen and the fluorine have got to go somewhere. Then it needs balancing. I've got 2 oxygens here, so I need 2 water molecules. And then I've got 4 hydrogens, so that's going to have to be a 4. So then I've got 4 fluorine, so I need 2 F2 as well. Using oxidation numbers, show what has been oxidized and what has been reduced in this reaction. Okay, so if we're going to go with the oxidation numbers, then fluorine here is the element, so it's going to be its oxidation number is going to be 0. And then here, fluorine is going to have an oxidation number of -1. Okay, so fluorine, if it's gone from 0 to -1, it's been reduced. Okay, so fluorine has been reduced as its oxidation number goes from 0 to -1. And then what's been oxidized, the hydrogen here is going to be +1, and it's still going to be +1 there, so it's the oxygen that's changed, because oxygen is going to be -2 here, and then it's going to be 0 because it's an element. It's usually a good thing to spot. If you've got anything that's an element in a reaction, that's going to be changing its oxidation number, because it'll be 0 in the element and it'll be something in a compound. So anything where you've got elements on their own is a good one to look for when you're looking for oxidation numbers. So if the fluorine has been reduced, so the oxygen must have been oxidized. You can't have one happening without the other, as its oxidation number goes from -2 in the water to 0. So its oxidation number has increased, so it's been oxidized. Okay, if we have a look at some other questions here. We're saying here, ions of group 7 elements take part in displacement reactions. We've seen this already. These reactions can be used to compare the reactivities of the elements. Fine. We're adding aqueous solutions of halogens to test tubes containing solutions of halide ions. The resulting mixtures are then shaken with cyclohexane. So remember, this is going to change the colours. The problem with if you just do it in water is that the orange of the bromine and the sort of browny colour of the iodine are a bit similar. So using the cyclohexane is going to give us a different colour. Okay, and it wants us to complete the tables to show the colours. Okay, so if we add chlorine to iodide ions, then the chlorine will displace the iodide and we'll get iodine being displaced. And if iodine is in the solution with cyclohexane, you end up with this purple colour. And that distinguishes it from the orange. Okay, that's the point of adding the cyclohexane, to make it much clearer. If we add bromine to chloride ions, the bromine is not going to be able to displace the chloride ions. Okay, so this reaction is not going to happen. Nothing's going to happen here. So we're going to get the orange colour because the bromine is still going to be there. Okay, so that's still going to be orange. There's going to be no reaction. Write the ionic equation for experiment 2. We saw this on a previous question. It's actually the same one. So we've got chlorine and there'll be 2 bromide ions and they'll get displaced and we'll end up with 2 chloride ions and we're going to get the bromine, which gives us the orange colour. These 3 experiments alone are unable to confirm the order of reactivity. Suggest one further displacement reaction. Okay, so what have we shown? We've shown that chlorine will displace iodine. We've shown that chlorine will displace bromine. So we need to do the reaction involving bromine and iodine. Okay, so we need to add Br2 to a solution containing iodide ions. So then the bromine will displace the iodine. Or we could do it the other way around. We could add iodine to a solution with bromide ions in, and then there wouldn't be a reaction, and that would also show us that bromine's more reactive. But I think that's the more straightforward way of doing it. Okay, then we've got this reaction here of chlorine reacting with water. This is a reaction that you do need to know. But here they've given it to us. Using oxidation numbers, explain why this reaction is an example of disproportionation. Okay, well, disproportionation, it's going to want us to just give a definition of that. Disproportionation. You've got to watch the spelling of this one. It's a nightmare word. Disproportionation occurs when the same element is both oxidized and reduced in a reaction. So here it's the chlorine that's going to be oxidized and reduced. So chlorine is oxidized. Let's just have a chlorine atom. Chlorine is oxidized from 0, because it's the element, to, right, what's going on here? So here we're going to have hydrogen's oxidation number is going to be +1, oxygen is -2. So here the chlorine is +1, and here the hydrogen is +1 and the chlorine is -1. So chlorine is oxidized from 0 to +1 in HClO, and chlorine is reduced from 0 to -1 in HCl. Okay. So that then shows us that it is disproportionation because it's been oxidized and it's been reduced. Okay. And it's good if we can link it to which chemical it's come from. Finally, so this was chlorine reacting with water. What is the benefit of doing that reaction? Why do we add chlorine to our water? Well, it kills bacteria. Okay. This is why you have chlorine in swimming pools and this kind of thing.